Right now, today is very slightly longer than yesterday. Not by a second you'd notice, but it's true, and it will never reverse. The reason is 384,000 kilometers away, quietly drifting further from you every single year. The moon is leaving. Every year, the moon moves about 3.8 centimeters further from Earth. That's roughly the width of your thumb, gone into deep space every single year for billions of years running. You can't see it happen, but scientists have measured it directly, bouncing lasers off mirrors astronauts left on the lunar surface in 1969, timing the return trip down to a fraction of a second. Here's why it matters to you. The moon's gravity doesn't just pull the oceans into tides. As it drags on Earth's oceans, it drags on Earth itself, like a hand dragging on a spinning globe. That drag slows our planet's spin down. And when Earth's spin slows, the day gets longer. Right now, Earth's day is lengthening by about 1.5 milliseconds every century. Tiny. Almost imaginary? But multiply that by deep time, and the story flips upside down. 620 million years ago, a day on Earth lasted about 21 hours, not 24. The evidence is fossilized in ancient coral, whose growth rings show daily and yearly bands like tree rings, proving a year back then packed in about 400 shorter days. Dinosaurs 70 million years ago lived through days close to 23 hours long. They never experienced a single 24-hour day in their entire existence. Every day since the planet formed has been slightly longer than the one before it, and every day of your life will be too. So, where does the energy go? It can't just disappear. The spin Earth loses gets handed directly to the moon, like passing on speed in a slingshot. That's exactly what pushes the moon further out. Earth slows down, the moon speeds away. The two are locked in a trade that never stops. Eventually, in the very distant future, this trade could balance out completely in a state called tidal locking, where Earth's day and the moon's orbit match exactly. If that ever finished, Earth's day would stretch to around 47 of our current days long. One sunrise, then weeks of night, then one sunset. But it won't get there. Long before that could ever finish, in about 5 billion years, the sun itself will swell into a red giant and make the question meaningless. Still, you're living inside this drift right now, today. And it's why timekeepers have to add leap seconds to official clocks every few years, just to keep our watches synced to a planet that keeps quietly breaking. None of this is a future problem. It's happening in this exact second, at a rate too small to feel and too real to stop. The moon isn't just a rock hanging in the sky. It's the reason your grandmother's day was a fraction of a second shorter than yours. It's the reason a Devonian coral's day, hundreds of millions of years ago, was 3 hours shorter still. You will never live through the same length of day twice. Every sunrise is slower than the one before it, stretched out by a rock 384,000 kilometers away, quietly slipping into the dark, one thumb's width at a time. This isn't just an Earth story. Every planet with a large enough moon plays out some version of this same slow trade. Mars is doing the opposite trick with its moon Phobos, which is spiraling inward instead of outward, and is expected to eventually break apart or crash into the surface. Earth got lucky. Our moon is large enough and close enough to have stabilized our planet's tilt for billions of years, keeping our seasons predictable instead of chaotic. Without the moon's steadying pull, Earth's axis could wobble wildly over time, the way Mars's axis has, swinging from mild seasons to extreme ones over tens of thousands of years. So the same objects slowly stealing seconds from your day is also the reason your calendar makes sense at all. The reason winter reliably follows summer instead of arriving at random. The moon is both a thief and a guardian, stretching your days by fractions of a millisecond, while quietly holding the whole system steady enough for anyone to be here counting.